It's not. Oh, there we go. I'm using Open Broadcaster software. Whenever I first started recording, it started not responding, so I do apologize if I did pause right in the middle. My name is Texas Noe. I represent Group 3. The members of our group, our group. Anyways, of our group is Ryan Vanderhyde, Kay Chandler, and myself. Landon Birch was a group member at first, but he stopped communicating with us, so I believe he just is no longer a part of our group because of that. So essentially, let me bring up the script. I'm so sorry, I'm kind of reading from a script. I have a display on this side, and then my main display is right here. So just bear with me for one moment. I do have to move some things around. There we go. Okay, so let me readjust. Okay, so the problem that our group decided to fix was overcharging devices. The danger in overcharging devices is that it lowers the lifespan of the battery, and for some devices that means the life of the device. The original scope of the problem was too broad since most devices have different charging requirements, so we decided to focus on a specific device, and that device was Ryan's laptop, Ryan Vanderhyde. Our solution to the problem, after some individual research and group discussions, we decided that the best way to solve our problem while meeting our design constraints was to use an external battery array to store the charge that would otherwise overcharge the battery. This had all our constraints and requirements. It would function with the laptop, be portable, be durable, and simple to use. Since the size of the device is under 2 cubic feet, it fits in the laptop bag with the laptop. The design of the device allows it to be made from tough, cheap plastic, which I'm using PLA. Well, technically PLA plus, so a little bit more durable. And also has a very long lifespan and uses reusable AA batteries. It means cheap. Even if the batteries just die, you can just replace the batteries. The use of the device is simple. All the user has to do is to put it underneath the laptop on the back, plug it in, and it starts to work. As far as testing, the testing that we decided to do was to test how different angles affect the airflow and temperature of the laptop. We did not measure airflow. The only thing that we did measure was temperature, which that will be in our report. We accomplished this by elevating the back of various laptops to predetermined heights to find the best angle to use for airflow. Our test showed that the best height is around 1 inch, which is around 5 degrees, measuring from the front to the back, relative to the surface that it was on. This now defined the size of our device and ensured that it remained portable and under 2 cubic feet. For the design process, we utilized all steps of the design process to make this device function better. Unfortunately, we did not have time to use the process multiple times to create a perfected version of the device. For us, the most important step was getting a prototype made so we can see how it would function outside of just our thoughts. The way that we accomplished this was 3D printing the model and visually seeing how the device will be used. Testing was also an integral part, so we would know what size the device should be. As far as group work, the way that we divided up group work was as evenly as possible. If one person did the 3D model, another person tested it, another person made the physical version of the model. We just meet together and discussed who is most comfortable doing what and who wanted more practice with the task, and that's how we decided who did what. To reiterate, basically one person would design it in computer-aided design, which was, I can't remember the name of the program that we used. But anyways, they would CAD the model, and then so in this case, Ryan Vanderhyde would CAD the model, and he would give it to me, and then I would take that CAD model, convert it to an STL file, throw it into Creality Slicer, turn it into a G-code, throw it on my 3D printer right back here. If you hear the 3D printer, I do apologize. And make a physical version of the model, and then I would pass it on to Kate Chandler, and he would test it on his device. I also did some testing on my devices as well, which is the laptop. As far as the physical version, this is what we came up with. Sorry, what my camera sees is over here. So essentially this is the charging port, and then this would be the part for the batteries. It would take AA batteries, which I believe it would be 2 rows and 6 across. The problem with this is that the charging port, because it's only made for a specific device, it would only work for Ryan's laptop. Different laptops have different charging ports located at different spots on the laptop. For my laptop, the charging port is located on the back, slightly off center. And also, another thing is that laptops take in air from different places. For Ryan's laptop, his laptop takes in air from the left and blows out to the right. For my laptop, it takes in air from the bottom and then blows out the back. So, essentially, this would only be useful for those laptops that take in air from the bottom and then blow it out elsewhere. This wouldn't be very useful for Ryan's laptop, for example, which takes in air from the side and then blows it out the other side. So, to fix one of the two problems, which is with the charging port, what I thought of was, instead of the charging port being a fixed spot, instead of doing that, it would be on a cable, and that cable would end up going to a magnet coil, and that magnet coil would contain the charging port, and that charging port can be swapped out for another charging port that would be compatible for the laptop, or the desired laptop that it would charge. And that would fix one of the two problems. As far as air, unfortunately, I'm not entirely too sure exactly what could be done in order to get better cooling. There's a reason why I'm printing another one of these. If you could see in the background, my 3D printer is going off, and the platform adhesion on this kind of stuck a little bit too well, so I'm having to 3D print another one of them. If you need any pictures, Professor, I will be submitting them after another one of these prints out. Other than that, that's pretty much all I have to say about the project. As always, thank you for watching.